So the first thing I would do is sketch a quick graph. Y equals x squared. Of course, is a parabola, looks like that. Y equals 2x plus 3 is a line that looks something like that. We are finding this area in here. So what I'm hoping you guys realized was, well, we need to find points like where it starts and where it ends. And then what I saw on almost all of your boards was, let's take the area under this line as though it went all the way to the x-axis, right? Take that whole area and then subtract the area under the parabola. And then what's left would be the area in between, right? Okay, so very good thinking. So first let's find our points of intersection. So this is a nice lovely system. So I'm going to use substitution and substitute my y in this equation for 2x plus 3. So I get x squared equals 2x plus 3. X squared minus 2x minus 3 equals 0. Favorite F word. So we have, yes, it is factor. 3, 1 minus plus. So 3 and negative 1. All right, so we know we're going from negative 1 to 3. All right. So if you have the same limits on two separate integrals, negative 1 to 3 of 2x plus 3 minus negative 1 to 3 of x squared, you can just write it as one big integral. And that's what I'm going to make you do starting today, because we're going to have so many integrals over the next couple weeks. So negative 1 to 3 of this line, 2x plus 3, minus the integral from negative 1 to 3 of the parabola x squared. This whole thing now is one big integral. All right, so now we anti-differentiate. So antiderivative of 2x, yell it out. Antiderivative of 3, antiderivative of x squared, third x cubed, evaluated from negative 1 to 3. I still haven't told you the 1/3 x cubed joke. All right, I will eventually, but not today. All right, maybe Wednesday would be a good day for 1/3 x cubed. All right, so plug in the 3. So you get 9 plus 9 minus 9 minus, plug in the negative 1, you get 1 minus 3 plus 1/3. So you end up with 9, 1 minus 3 is negative 2, but it's minus, so you get plus. 9 plus 2 minus 1/3. So 11 minus 1/3 is 10, and 2/3 or 32. Okay. So, well done to the couple of the groups that actually got it numerically correct. That was good. I know. I'm aware. I'm very aware of your computational mistakes. Yes. Yeah. So that's Calc 3 when you all take Calc 3 next year, and you will. Calc 3, my students, the most complicated multiple integrals, really crazy setup, get the whole thing done in converted coordinate systems and everything, and then they still can't say that 1 plus 3 is 4, right? That's where the mistakes always lie, is in computation. Yep. Okay. Okay. So today we're starting chapter 6, which is applications of integration. The applications that we will be studying in this unit are area, volume, average value, and arc length. We will not do surface area in this unit. We'll do area, volume, average value, and arc length are the 4 applications we're going to study. I'm going to pause this for a moment. Actually, you know what? I'll leave this on the video. Okay. Where did I put that? Okay, calendar. Just so you know where we are headed. Okay, this is just kind of a rudimentary calendar that Ms. Grunwald and I use to kind of help plan. So we are here, right? It is Thursday, December 5th, and we are doing area between curves. We're right on track. The next 3 days will be on volume.
volume with using discs, volume using washers, volume by cross-section, and volume by shell. Once we finish all of the volume sections, then we have a day on average value and a day on arc length. So you have 3 we don't write big quiz on this calendar, but the big quiz would either go Friday or Monday, depending on when we feel like doing it. Probably Friday. I think I would rather big quiz Friday. I liked that better with this past unit. I liked doing the big quiz, going over the big quiz, and then still having an additional day after that, as opposed to reviewing first, then big quiz, and then going over it and then taking your test. I don't know. There's goods and bads to both. But I think I am going to kind of push for big quiz on Friday the 13th. Oh, so it'll be good. Okay. All right. So your next test is less than 2 weeks away. It's a really short unit. Your next test is December 18th, which is my wedding anniversary. That's how we'll celebrate, right? By you guys doing well on your Chapter 6 test. Okay. Then we jump right in. There's 2 days before break, and we jump right in and start doing population growth and differential equations. We're not sure what we're going to do on this day. I'm guessing it'll be a quiz and some sort of review. We are not going to have a winter party. Okay. We go out and have a snowball fight. Okay. The arc length of the distance traveled by the snowball in the air. That would be real life application. I'm always getting scolded that I don't do enough real life application. Okay. All right. We come back from winter break and there's only 4 lessons and then we're done. With the whole semester, right? So you have 4 lessons: slope fields, Euler, separable differential equations, and logistic growth. 3 review days, and then your Chapter 9 test is January 15th, and then 4 review days, and then you take your final. Final takes 2 days to take. So that is, the FR means free response, MC means multiple choice. So we always do free response first because it takes longer to grade. Okay, so that's what's going on. So for you guys right now, very short unit, only 6 lessons, review, test, as opposed to the last unit, which was 12 lessons. It was a huge unit. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 lessons. So this unit, half the size of the last unit, and yet the test is worth the same. So, the other thing to keep in mind is that in this term, there are 4 tests instead of 3. Last term, there were 3 tests, Chapter 2, 3, 4. This term, you have 3 tests and a final, so the tests are worth a little bit less. So 80% is still tests. They're each equally weighted, so every test you take is 20% instead of 26 2/3%. So final is the same. Yeah, we just put in everything out of 100. So, yeah. Is that you? Okay. So, everything goes in out of 100. So, your total summative assessments would be out of 400 points, whatever your total points is. Yeah. All right. Today we're doing section 6.1. I can calculate the area between curves. Or you can just call it area. Sean, what are you looking at? I'm just curious. Is it code?
Yeah.
Oh, okay. Yeah, let's put that away. Okay. I thought it was something actually related to math. I wasn't trying to get I wasn't trying to single you out. I just was curious. Okay. All right. I have another warm up. I want you guys to do this in your seats. And what I'd like you to do is take a look at each of these graphs. There are 5 of them. This one's kind of, down there. So each of these graphs, and I want you to write an integral, one integral, for each one that would give you the area of the shaded region, all right? So for each graph, sorry, that's a B. I've just moved this up and cut off the little B. There we go.
Okay. So anyway, for each one, so you'll have one integral for each of these problems. Think of it as like 5 different problems. In your groups, I want you to talk about this while you're working on it and kind of check as you go. Don't work in isolation and then check at the end. Check as you go. Hi, Twiggy Ann. Can you hear me back there? You're quite far away. How are you? Are you? Okay. Twiggy Ann, what did you get for your integral that would give you the area for number 1? The integral from a to b of f of x dx. Beautiful. Everyone get that? Pretty straightforward. All right, well done. All right. Hi, Anthony. How are you? Are you? Good. Okay, what did your group get for the integral that would give us the area for number 2? A to b. So you did absolute value of f of x. Okay. If we don't have a calculator, do we like integrating absolute value functions? No, we do not. Okay, so is there another way that we could write this without an absolute value? Vishali. So this is correct. Nothing wrong with it, right? But this would also be correct. So either way. Did you guys I'm kind of curious. How many of you put an absolute value? 3 groups. How many of you put a negative? Okay. All right. You think your group did nothing?
Well, no, like we're confused. Like, is it like an integral like in that area? So yeah.
Can you have a negative area? Oh, you're saying net area. Oh, but I didn't ask for the net area. I want the area.
Like all the like the positive.
I want true area. Like if you were in geometry, yeah. What would you give me? Okay. So did you guys just put f of x because you were thinking net? That's okay. All right. So I apologize for not clarifying that. Okay. So, hi Tyler. How are you? I'm doing great. Can you give me an integral for number 3 that would give you the area?
Integral from a to b of f of x dx minus integral from a to b of g of x.
Good. That's absolutely correct. Could you kind of squish that into one integral for me?
A to b f of x minus g of x.
There we go. Okay. Is everyone okay with that? Did you all get something similar? Okay. All right. Hi, Emma.
Hi.
How are you?
I'm doing good. How about you?
Doing great. All right. Are you ready to give me an integral for number 4?
I could.
Okay. Let's do it.
It's the integral from b to a.
Oh, okay.
A to b.
Oh, there we go.
Same thing.
Not, but that's okay.
That's the same thing.
Just so you know, traditionally we say from low to high.
F of x plus the absolute value of g of x.
Oh, could we rewrite it without an absolute value? Did anyone have that? That's what you have is true. Oh, Jacob, yeah. Ah. Whoa. He's absolutely. Whoa. People are going like this, right? Now, how does that work? Well, the integral of g of x would be negative. We want to add this area, so if we do minus a negative, we're going to get a plus, right? And we end up getting the total area. All right. It's what we have written. Because this would be negative, so minus minus would give you the essence of plus. Okay. All right, last one. Charles. Hi, Charles. How are you? Are you? Good. You have a very happy smile. Okay. All right. So, Charles, can you give me an integral that would work? A to B. Yep. Okay. Let the group help him out. Be there for him, right? You guys are a team.
Isn't the actual value of g of x minus f?
Okay, you're really close. Really close. The negative g of x is correct. This would be a plus. Be a plus. So why would it be a plus? Because this f would be this area as a negative, right? So then this would also be negative. So the negative in front of here would make this big thing be a positive. The plus would make this stay negative, so we get plus minus this, and the effect, I don't want to say net anymore, the effect would be the area that's left over. I'm going to rewrite this, if it's okay with you, like this. Okay, so the area for problem number 5 was the integral of f minus g. The area for problem number 4 was the integral of f minus g. And the integral for problem 3 was the integral of f minus g. Do we see a pattern?
What's number 2?
Now, number 2 didn't have 2 functions. Number 2 was just that, but we're going to get to number 2, don't worry. If we have 2 functions, quick question, does the x-axis play any role in how we set up our integral? Really, it doesn't. It has nothing to do with it. So what does have to do with it? It's just the integral of whichever function's on top minus whichever function's on the bottom. Doesn't matter where the x-axis is. The x-axis can go right through it, can be above, can be below, makes no difference. It's just the integral of top minus bottom. So if you start to learn that area, this is not like a formal thing here, but that area is the integral of top minus bottom. You'll be made in the shade. So top minus bottom, get that ingrained because that's going to apply not just for area, but it's going to apply for volume and arc length and all kinds of crap. So when you're doing whenever you're doing problems in this unit, your brain should be thinking top minus bottom all the time, right? Should be the answer to the meaning of life, right?
42.
What is it? Okay, it's 42, but that's not the answer to the meaning of life. That's the answer to how many roads must a man walk down, right? So, okay, so the answer to the meaning of life is top minus bottom. Now you know, okay? All right, so if it's top minus bottom, let's go back to numbers 1 and 2. Number 1, the top function was f of x. What's an equation for this line? 0. So we would have f of x minus 0, right? Which we do. Everyone's looking ahead. Top function is 0 minus f of x. Whoa! Oh my gosh! Aren't these awesome? Top minus bottom. Top minus bottom. Right, Rashmi? Yes. Top minus bottom. Okay. So let that stick because that's going to apply to a whole bunch of problems, but not all, because eventually today we're going to turn everything around. But it does. That'll be fun. Okay. So this is just the book kind of reiterating top minus bottom. I don't want to get into it too much. However, I'm going to do the next example. So take a minute in your groups on paper. I want you to see if you can set up an integral and solve it, evaluate it, to find the area between y equals x and y equals e to the x from 0 to 1. Now, they've stretched it. This is not drawn to scale. If you look, this is 0 to 1 on the y-axis, and this is 0 to 1 on the x-axis, like really stretched, but it's still the same setup, right? So go ahead and see if you can write an integral to set up to give you this area, and then go ahead and evaluate it. Concept. What was the integral that you, whoa, woo, hang on. Okay. Now, what was the integral that you used? 0 to 1 of e to the x minus x dx. Lovely. Everyone get that? All right, Kostya, what's the antiderivative of e to the x? What's the antiderivative of x? X squared evaluated from 0 to 1. So you get e minus a half minus, what's e to the 0? 1 minus 0. So you end up with, oops, that's equal to e minus 3 halves. How's that sit? That good? Okay, good. All right. What if the same function as now is on top? Then you have to split the integral. Very good, Ishan. Okay, so here's the thing. If you have functions that kind of crisscross in multiple spots, you are going to have to set up an integral like from here to here of this top minus this bottom, and then from here to here of this top minus this bottom, and then from here to here of this top minus this bottom, and then add them all together. So always top minus bottom. So if top changes, you need a new integral. Okay? Let's practice one of those. So this is y equals cosine x and y equals sine x from 0 to pi halves. Notice the red function, that's cosine. The blue function is sine. From 0, they're really nice. They give you where they intersect. From 0 to pi fourths, cosine's on top. From pi fourths to pi, sine is on top. I want you guys to go ahead and set up an integral and solve it. That will give you the area, the total area of this region. First, check your setup.
I never had anything.
Okay. All right, check your setup. How does your setup look compared to my setup? Your setup looks spot on. Phenomenal. Okay, good. Now, I cheated. So I technically didn't cheat. I used math in my favor to make my life easier. Okay? So what can you do to make your life easier with this particular integral? Yes! Do you guys hear Ari?
Here's his idea.
Oh, really? Oh, Lucas. Okay, well done. Since these two areas are the same, now you have to know they're the same. And the reason we know they're the same is because sine and cosine are really the same function, just shifted, right? So these are actually symmetric over the line x equals pi fourths. So because of that, you can just take one of these areas and double it, right? Just to make your life a little easier. So I went ahead and just did the first integral from 0 to pi fourths and doubled it. So what's the antiderivative of cosine? Positive sine. What's the antiderivative of sine? Negative cosine. So you end up with sine plus cosine from 0 to pi fourths. Sine of pi fourths is root 2 over 2. Cosine of pi fourths is root 2 over 2 minus sine of 0 is 0. Cosine of 0 is 1. So you end up with root 2 over 2 plus root 2 over 2 minus 1. Everything doubled. So you end up with 2 root 2 minus 2. All right. Did the middle group, did you guys figure out
Yes.
What happened with all three of you? Okay. All right. Good. Moving right along because it's short period today. Oh, it's Thoughtful Thursday. We're going to take 30 seconds. Okay. So I want this on your whiteboards. I'm going to time you because we do have some other stuff to learn today. So, but I want to just caution you two things. Okay. Number one, there might be more than just 2 points of intersection. Make sure you find all the points of intersection. And so there might be multiple regions. Number two, I want you to evaluate your integrals on your calculator. All right? I want to set up on the board, but I want you to evaluate on your calculator. So I just want to see setup and answer. All right, so the first thing I did was I found my points of intersection. I just did it by hand. So 3 points, I got 0, -2, and 3. If you don't have a calculator and you need to know which function is on top, just so we know that we're going to go, if we go in order, -2 to 0 and then 0 to 3. So from -2 to 0, you just pick a number in between there, like -1. And you just plug it into each one and see which one gives you the higher y value, right?
Oh.
And then from 0 to 3, you just pick 1 and you just plug in again and see which one gives you the higher y value. Whichever one gives you the higher y value is on top, right? Okay. So anyway, I went ahead and combined like terms. So this, I didn't show it explicitly separated. My first one, the x, so from -2 to 0, the x cubed was on top. So this is x cubed plus 3x squared minus the quantity 4x squared plus 6x, just kind of put together, right? And then this one is the same thing reversed. So now it's 4x squared plus 6x minus the quantity x cubed plus 3x squared. So that was your setup. Make sure you have your setup correct, including the dx's and the limits. Everything gets counted for points on your test with setup. And then your answer, you just throw in your calculator. And the correct answer was 253/12 or 21.083. So well done. I'm assuming that's right. It looks like it's probably right. So, okay. All right. Yeah. Good. Okay. Did you guys find the mistake?
Yeah, we got it.
Okay. All right. Well, excellent. So the last thing we're going to talk about, this problem we're going to do together, this one takes a little bit of thinking. So I want you to stay with me and copy, okay? So go ahead and take a second, write this down. While you're writing it down, I'm going to go ahead and sketch a quick graph. And there's 4. All right, I'm going to do this really fast.
Shane Mosley, the student activity. Shane, the student activity.
Okay, so here's the thing. If we have y equals plus or minus the square root of 2x minus 2, which is the green graph, and then y equals x minus 5, which is the red graph, all right, so the region in between looks like this, right? Now, we could do this the way that we've learned today. We would have to split it up, though, because along this line, if you look carefully, you have, for this region, you have this top and this bottom. And then for this region, you have this top and this bottom. You have 2 different bottoms. Can you guys see that, why there's 2 different bottoms? Okay, so you could do it. It'd be kind of a pain, but it could be done. Or, instead, you could look at it sideways. If you look at it sideways, there's only 1 top and 1 bottom.
Yes.
Sean's shaking his head no, but there really is. Okay, good. All right. So we are allowed to do area top minus bottom or right minus left if it's easier, right? Right minus positive minus negative, right minus left. So how do we do right minus left? Well, with top minus bottom, the functions are solved for y, And so we have functions solve for y and our limits are x values. When we do right minus left, the functions are solved for x and the limits are y values. So what we're going to do, this is y equals x minus 5. So x, you solve it for x. X equals y plus 5. For this guy, y equals square root of 2x minus 2. Square both sides, you get y squared plus 2 divided by 2. So you get x equals 1/2 times y squared plus 2. And actually, this is the same equation because as soon as you square both sides, the negative goes away. So that's why it's a quadratic, right? It's a sideways quadratic. Whenever you break a quadratic up for the other variable, you get plus or minus a root. So anyway, but here you get this lovely sideways quadratic. All right, so now if we do right minus left, so our area would be the integral of the function on the right minus the function on the left. Instead of dx, now we're going to be dy, which means our limits have to be y values. So now, instead of going left to right with the limits, we have to find that guy and that guy. So you have two options. You can find the x values and then plug them in, or just find the y. I'm going to find the y values. So if we set our x functions equal to each other, we get 1/2 times y squared plus 2 equals y plus 5. Y squared plus 2 equals 2y plus 10. Y squared minus 2y minus 8 equals 0. Factor y minus 4, y plus 2. Y equals 4 and negative 2. We're going from negative 2 to 4. So this would be like negative 2. That would be 4. So you do this. Now, if you have to enter an integral on your calculator that is dy, you are welcome. If you're on an 89, you can type it with the y's and it'll be fine. The 84s, 83s, 84s, you still have to use that variable button. So it's going to put x, right? Because you're hitting the variable button. That's okay, because mathematically, whether this letter is an x or a y or a q, it doesn't matter. The math is the same, right? The calculator doesn't know that you looked at it sideways. It's just going to crunch the numbers, right? So it's okay to type in a dy integral with x's into your calculator if you need to. All right, last little slide, and then we are done. Not that one. That's just them showing what it looks like. Okay, so in general, if you're going vertically, like a vertically oriented graph with a top and a bottom, then it's the integral from a to b of top minus bottom. If you want to turn it sideways, then it's the integral from a to b of right minus left. Top minus bottom, your limits are x values. Right minus left, your limits are y values. All right, we had more to do, but there's no way we have time. So I might do the AP problem that I had for you as a warm-up tomorrow instead. All right, that's it.